Hello YouTube, and today I'm going to be making a video on even and odd functions. Even and odd functions. What the heck are they? This question plagues a lot of students and causes them to stay up late while I'm here to clear all doubt and uncertainty. So basically, we've studied many different types of symmetry, even when we were young in elementary school. But a function is even if its graph is symmetric with respect to the y-axis. So I'll just show you what that means. Like, that's the y-axis, right? It's like a parabola. It's symmetric around the y-axis, because if you flip this side onto this side, they would line up perfectly. And a function is odd if its graph is symmetric with respect to the origin. So basically, let me just correct this stuff. Okay, so a classic example of an odd function would be y equals x cubed minus x. So let me just draw that here. One minute. And then it's symmetric about y equals x. And then there are many tests you can use to notice and to tell whether a function is even or odd. I'll go over those now. So a function f of x is even if and only if, and the converse is also true, f of negative x equals f of x. Meaning that, let's say you have a parabola. This point here is has the same y value as this point here, and the same distance from the origin. So yeah, this would be 1, and this is negative 1. So yeah, they have opposite values, but they both map to the same y value. So that's what that means. And then the other rule you could sort of use is that a function is odd if f of negative x equals negative fx. So that just means that, let's say you have this function. Y equals x cubed. This point here and this point here are opposites. So this would be 1 and this would be negative 1. 1 maps to, let's say, 5, but negative 1 maps to negative 5. Okay, so that should get you a good idea about what the heck inverses are and even and odd functions, even and odd functions. So I'm just going to draw a few noteworthy even and odd functions that teachers will probably give to you. Sorry, my axis is totally messed up. So we have a very common even function, of course, the parabola, centered on the y-axis. And then we also have the absolute value function. And then a common odd function would be the cubic function. And here's a general rule of thumb to consider when you're determining if a function is even or odd when you're given the equation. If the highest x term exponent is odd, it will generally be odd. If even, generally even. Okay, so I know my handwriting sucks. Okay, so let's say you have y equals x to the 1024th. We don't know what this looks like, but because this is even, we can say that this is an even function. Let's say you have y to the y equals x to the 97th. We don't know what this looks like, but because of end b behavior and all that, we can tell that this will be odd. And we can also use end behavior, which is basically means how the function will react at positive infinity and negative infinity to predict what these might look like. So basically, let's say you have a huge positive powered exponent, you can pretty much tell that its ends are going to look like parabolas. And then if you have a huge odd powered exponent, you probably can infer that one side may go up, one side may go down, something like that. Maybe something like that. So yeah, that should get you a good intuition on what even and odd functions are. If you enjoyed this video, make sure to like, comment, subscribe, and first of all, share this video with your friends and classmates.